Okay, here's part D. So it is known that g of x is less than or equal to h of x from 1 to 3. Let k be a function satisfying that k is somewhere in between g and h for 1 to 3. So is k continuous at x equals 2? Okay, so let's go back to this idea here, okay? So we know that g and h are continuous, okay? We know that g and h are continuous. So since g and h are continuous, at x equals 2, okay? We know that g of 2 is equal to 4, and we know that h of 2 is equal to 4. So let's take a look at this. Since g of x is less than or equal to k of x is less than or equal to h of x, okay? G of 2 and h of 2 have to come out to 4. So is k of 2 continuous as well, right? So this right here, if k of 2 has to be greater than 4 or greater than or equal to 4 but less than or equal to 4, there's really only one option that it has. K of 2 has to be 4. Now, more specifically, this is called the squeeze theorem or the sandwich theorem. You're squeezing in the value, leaving it no choice but to only have one output. Okay? So is this enough to really give you a conclusion, right? So all we did here was we checked the second condition, that it was defined, okay? Now we got to check for the limit. Well, what's the limit of g of x as x approaches 2? We know that that has to be in between the limit of k of x as x approaches 2 and the limit as x approaches 2 for h of x, right? We know that the limit of g of x let's see. So that's the same idea. Since g and h are continuous, we know that the limits will have to equal the defined functions for g and h. Okay? We don't necessarily know what the limit of k of x is yet, but if you notice, the limit of k of x as x approaches 2 got sandwiched in between two of the same values. So that leaves this no choice to say that the limit of k of x as x approaches 2 has to be 4 as well. So we figured out the first one here. We have the second condition here. Well, the third one is the limit of k of x as x approaches 2, is that equal to k of 2? And in this case, it is. Therefore, we know that k is continuous at 2. Okay? Now, personally, I think they threw this in here to just kind of see what kids would come up with, but they didn't see a lot of success with this one here, okay? So I wouldn't worry too much about it, but it's good to know because the sandwich theorem or the squeeze theorem is discussed in future math classes, so just keep that in mind, okay?